Welcome back to Miss B Makes It Easier, and we're now moving into group 7, and they are called the halogens. Right, so let's move on. And group 7, do note that group 7 is sometimes referred to as group 17, and that's if we include the transition metals. Remember, these are the transition metals here. In earlier videos, I would have told you that they're ignored, and that's because we don't really pay too much attention to them. However, some of them are taken into consideration throughout your studies in chemistry. Things like chromium, manganese, iron, copper, let's see if any more here, gold, not really gold, but silver. You will see a lot of things you're dealing with in silver, right? So those are the main ones. So again, chromium, manganese, iron, cobalt, nickel, well, not nickel, copper, and silver, right? And so these are the halogens right here: fluorine, chlorine, bromine, iodine, acetylene, and then you have, right, so those are there. These are the ones you pay attention to. However, acetylene is so unreactive, we don't care about it so much, so we stick with fluorine, chlorine, bromine, and iodine. That's the lowest we will go in the halogen family. So the elements of group 7 in order of first to last are fluorine, chlorine, bromine, iodine, and acetylene. And like I said again, we don't really bother with acetylene because acetylene is not very reactive. It's not reactive at all. It's very, very slow. So we don't pay attention to it. Okay? So the group 7 elements are called halogens. They all exist as diatomic molecules in nature. For example, F2, Cl2, Br2, I2, and A2. So just as the picture suggests, in nature, two atoms of itself, they bond covalently. And we're going to get to bonding soon. Okay? So they bond covalently, and in nature they exist as diatomic molecules. Whereas in nature, noble gases exist as monatomic atoms. They just float around singly and happily because they would have had complete octets, or they would be satisfied. There's no need to bond. So their colors get darker as you go down the group. So fluorine would have a yellow color, chlorine would have green, bromine brown, iodine is a pretty purple, right? Now the states of these elements would be at room temperature. Fluorine would be a gas, chlorine would be a gas, bromine a liquid, and iodine a solid. So as you realize, the states change successively as they go down. We start with a gas, then we move on into liquid, then solid. So going down the group, their melting and boiling points increase, and that's because they get larger. Okay, they get larger, and so there's more bonding going on, intermolecular bonding going on, right? And so the reactivity of the elements decrease, and the radius of the halogen atom increases. So as you can see, when you move down the group, you realize that the distance here, the radii between the two, gets larger and larger. And that's because of the presence of more electrons, and because of the presence of more electrons, you have more electron-electron repulsion, and they just start to spread out wider and wider and wider. So halogens are referred to as strong oxidizing agents. This means that they are willing to accept electrons willingly, because all they need is one more electron to fulfill their octet. Fluorine is the strongest oxidizing agent of the halogens due to strong nuclear charge, while acetylene is the weakest halogen due to weak nuclear charge. So halogens are involved in displacement reactions. A displacement reaction is a reaction in which one type of atom or ion has replaced another in a compound. In displacement reactions, fluorine can displace all of the halogens below it. Chlorine can displace all of the halogens below it except for fluorine and so forth. So therefore, iodine can displace all of the halogens below it, but it can displace fluorine and chlorine. Okay, so what I mean by displacement reaction, let me see if I can give an example. Well, first let's talk about the completing of the octets. So with the octets, you will have fluorine here. Remember, this is fluorine, and fluorine has 9, right? So 9 protons. And so you would have 2 in here, and out here you would have 7. 1, 2, 3, 4, 5, 6, 7. So what is happening here is that fluorine wants to it wants to obtain a complete octet. This empty electron, this is where it's supposed to have 1 more to make it 8. Fluorine is dying to have an extra electron. So it is highly electronegative and it is willing to accept that extra electron to attain or obtain or maintain stability. Not maintain, but obtain stability. Right? So that's what I mean by obtaining a full octet. Now, for displacement reaction, what I meant was that suppose you have fluorine here. You have fluorine right here, and you have hydrogen chloride. Right? Fluorine can displace the chlorine because fluorine is higher than chlorine. Okay? So means you get HF, you get HF plus Cl2. So you probably have a 2 here and a 2 here. Right? So you will get something like this. This is able to displace the chlorine here. However, if I put Cl2 plus HF, there will be no reaction. Alright, so like I was saying, was that chlorine doesn't have that power to displace fluorine. So you have fluorine, chlorine, bromine, iodine. Right? So remember, these are the 4 that we deal with. So in other words, fluorine can displace chlorine, it can displace bromine, it can displace iodine. Okay? So this has all the power. Chlorine can displace bromine and iodine, but it cannot displace fluorine. Bromine can displace iodine, but it cannot displace chlorine or fluorine. Okay? So that's what I mean. And iodine can displace any of them because it's the one lowest. So in displacement reactions, again I'll repeat this, fluorine can displace all of the halogens below it. Chlorine can displace all of the halogens below it except fluorine and so forth. So now you know why. And that's it for fluorine. So again, before I leave, let's look at it. The halogen family is just before the noble gases. It's to the left of the noble gases. Okay. Our main ones that we deal with are fluorine, chlorine, bromine, and iodine. Don't deal with acetine because acetine is very unreactive. Okay. We call them the halogens, the rhyme: fluorine, chlorine, bromine, iodine, and acetine. Okay. Then we have here some pictures of them and how they look. Fluorine is green in color, well, yellow in color. Chlorine is green in color. Bromine is brown. It's very heavy and it's liquid. It's liquid and it can, when you heat it up, it becomes a gaseous form. Iodine is purple. It's beautiful and it can go through sublimation. It can go directly from solid to gas or from gas to solid. Okay, so yeah, and these are the symbols: FCl, Br, and I. Okay, and so pretty much that's it for halogens. Thank you for watching. See you on the flip side. This was really short and fun.